Okay, now here is kind of a basic shape. I have to grab this with two different fingers. I'm going to be able to orient it the way I want to. Okay. Now, we've got an edge running here and an edge running here. And those two edges come together at this point. If these edges are straight, then I can take something flat. This set of directions, or whatever it is relatively flat. And I can just kind of lay it in there. Okay, and there's a plane that contains both of these edges, and it's a plane in three-dimensional space. I can do the same at this point. Okay, we've got two edges here and here come together at this point, and I can lay this plane down here, and it's different than the plane I get on the opposite side. On the back here, okay, I've got two edges, and I can lay a plane on that, and you see where that is. And I can come at the front and lay this down here. And you can do the same with your shape. I get four different planes. The thing that defines the orientation of a plane is a vector, and it's a vector perpendicular to the plane. If I change the orientation of this plane, if my finger is perpendicular to the plane, if I change the orientation, the direction of my vector changes. So this vector, any vector perpendicular to a plane, is perpendicular at every point of the plane. Okay, here, well, I can't go through it, but so there is a unique direction for a vector, and if you do a unit vector perpendicular to the plane, well, there's still two possibilities, one that goes this way and the one that goes the opposite way. They're both perpendicular, and we'll distinguish between the two, and that's not too important right now. So the first thing we need to do if we want to mathematically define a plane is we want to define the direction of that vector. I think I said it's called the normal vector. Okay, it's a unique, that's a vector with that at least lies along a unique direction in space. Whether it goes this way or this way, it's along a well-defined direction in space. Okay, so one of the things we want to do is we want to be able to calculate that normal vector. And it's pretty easy to do. If we've got two vectors in the plane, and of course we're doing the plane that contains these two vectors, then this vector's in the plane and so is this one. If we've got two vectors in the plane, we can calculate what we call the cross product of those vectors, and it's going to be perpendicular. Now I'll tell you, it's easy to calculate the cross product, but I'm not going to tell you right now how to calculate it. Okay, well this vector would be QR is this way, RS is that way. I don't have it exactly in the right orientation for this picture. We're not going to redo it. So it's called a cross product. It's kind of a multiplication. And it's not an obvious multiplication. It's a little difficult to understand why the multiplication is as it is, but it works. Okay, and I'll give you some explanation of that. Okay, so here's the vector RS cross QR, and it's perpendicular to the plane containing QR and RS. Now, of course, I can do that at any corner. I could do RS cross SP or SP cross PQ, or PQ cross QR, and get normal vectors to the planes that I'd have here, here, and here. And from what you saw that the planes are very different. Okay, they have very different directions, very different orientations, and they go through different points too. Okay, so once you have the normal vector, then all you need is a point. And we know this point here. This point it's the R point, it's 2, 2, 11. So now we have a normal vector and the point 2, 2, 11, and we're going to easily be able to calculate the plane. And I'm going to ask you to do that after we go over the calculation scheme and how you get a plane. Okay, that's one thing we can do. Another thing we can do is we can calculate the angle between two vectors. Okay, so angle between two vectors is theta, where there's another product we can do with the vectors. Where it's kind of like this. Okay, if we're trying to find the angle between RS and QR, we do this thing called a dot product. It's very easy to calculate. Very, very easy to calculate. We do RS dot QR. That almost looks like a minus sign, like making a good dot. And this thing that's so easy to calculate equals, running out of room, might have to overwrite A here. It's the magnitude of RS, just plain old multiplication, times the magnitude of QR, times the cosine of theta. Now the cross product is a little messier to calculate than the dot product. The dot product is really, really, really easy. So I'm going to give you an introduction to the cross product and the dot product in the next clip. Got to erase some board here.